this video, we will be discussing about construct string with repeat limit. You are given a string s and an integer repeat limit. Construct a new string repeat limited string using the characters of s such that no letter appears more than repeat limit times in a row. You do not have to use all characters from s. Return the lexicographically largest repeat limited string possible. So what they are saying is that in the input, we are given a string s and we are given another integer repeat limit. Now what we need to do is that we need to create a new string which is known as the repeat limited string. Now this string has to be lexicographically largest, right? What does it mean by lexicographically largest? So if let us suppose that I have a string where Z comes first and C comes after. And then I have a string where C comes first and Z comes after. So this string is lexicographically larger to this particular string. Why? Because the larger character comes first. So lexicographically largest means that the larger character comes first, then the next larger character Z, then Y, then X, and so on till A. Right? So if Z comes first and C comes after, this is lexicographically larger as compared to when C comes first and Z comes after. Right? So since we want to create lexicographically largest string, what we can do is that first we can consider all the letters which are the largest. Basically, we can find how many Z are there and then we can append those many Z's here. Then we can find how many Y are there. So Y is not present over here. Then you can check for X and so on till A. Right? So Z we have 2 over here. So we will append 2 Z's in our answer. Right? Next you will check for other characters, but the next character that you will find present in the string S will be character C. Right? Now C is present 4 times. Right? So we will append this. But hold on. We are given another integer also which is repeat limit. So this tells us that in our string, a particular character cannot be present consecutively more than repeat limit times. So in this particular case, any of the character cannot be present more than 3 times in a row, basically consecutively. So now the occurrence of C was 4 over here. We cannot append all 4 characters together here, right? Because it will exceed this limit, right? So we will append only 3 characters. So whenever a particular character is exceeding the repeat limit, what we can do is that we can take the next character, right? We can take one frequency of the next character just to make a breaker in between. And then we can append the remaining C's, right? So for C, next character would be A. The count is 2. We can take one of the A's and then we can append the remaining C's, right? So we will append our remaining C. Now, if let us suppose this A was not present, in that case, there would be no breaker for breaking the consecutiveness of our C's. In that case, we would stop here itself. We would not append the fourth C because we are not having a breaker, right? So it is not necessary to include all the characters from the string S, right? So now for C's we are done. Now the next character would be A. The frequency was 2. 1A we have already used here. The remaining one we will use here and our string will be completed, right? Now, why didn't we consider this A here? We could have considered both occurrences of 2 here itself. Basically, Z, Z, C, 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 A, C. This would also have been valid, right? But no, think about this. We need to return the lexicographically largest string, right? In these 2 strings, if you will see, till here, they are same. But after that, this one is having C and this one is having A. So this is lexicographically larger as compared to this string, right? So that is the reason whenever a particular character is exceeding the repeat limit and we want to introduce a breaking character in between, we will take only one frequency of that character because that character will be smaller than this character, right? So we want the remaining occurrences of it to come later on so that we create lexicographically largest string, right? So this has to be returned as our answer, right? So now how are we going to solve this? So see, since we know that in our string we will always have the alphabetical characters in lowercase, right? That is A to Z. So these are 26 characters, right? So what we can do is that we can create an array of size 26, right? To count the frequency of each of the characters inside our string, right? So this will be of size 26. This is the 0th index, first index, second index, and so on. Then this will be 24th, this will be 26th, right? So this will store the count of A, B, C, and so on. This will store Y and this will store Z, right? So what we can do is that we can update the frequency of all the characters from string S inside this array, right? So the count of A is 2, B is 0, C is 4, Y is 0, and Z is 2, right? Then what we can do is for building our string, we know that we want to create lexicographically largest string. So we will start from the end of the string, right? Basically, we will create a variable current which will tell us the index of the character that we are considering in this particular array. So this we can start from 25 all the way till 0, right? So first it will check that, okay, at the 25th index, what is the count? So if that count is 0, we will simply ignore it and we will move to the next index, basically current minus minus, right? But here it is 2, right? So then that means we need to append Z 2 times inside answer. But before appending this, we also need to check whether it is within the limit or not. So what we will do is we will take the minimum of repeat limit and the frequency, right? So in this particular case, 2 is the minimum. So we will append Z 2 times in our answer, right? So now that we have done it, the frequency becomes 0. So now when we have seen that, okay, the frequency of Z has become 0, then that means we can move on to the next character. So we will do current minus minus. We will come to Y. This is also 0. Then you will come to X. That will also be 0. And you will go on till C. So when you will be at C, you will see that, okay, its frequency is 4. So now again you will take the minimum of 4 and 3. Now here 3 will be the minimum value. So we will append only 3 times, right? C will be appended only 3 times and its frequency will now become 1, right? Now you will see that there is still some frequency remaining for C, right? So what you will do is that keeping your current here, you will start going backwards with some other variable to find out that which is the next character that we can use, right? So you will come at B, you will see the count is 0. Then you will come at A, you will see now here the count is non-zero. Then that means I can consider A, right? If let's suppose you have considered all of them and none of them were non-zero, right? So you will come here at the index -1. So there you can just break out of the loop and this string will be your answer, right? But here at A, you will get a non-zero value. So you will take only one frequency of this A and you will append it here and you will decrement its frequency by 1, right? So now that we have done this, we won't be changing our current because it was non-zero. The value is still non-zero. The frequency is still non-zero. So we won't change the current, right? So in the next case again, it will see that, okay, the frequency is non-zero. The minimum of these two is 1. So I need to append 1C over here. Now its frequency will become 0. And now we can move towards the left. Then it will come to B, frequency is 0. Then it will come to A, the frequency is 1. We will take the minimum of these. So A will be appended 1 time. Frequency will become 0 and then we will move left and we will be done with all of our characters and this will be our answer, right? So let's quickly look at the code. So first of all, let's create a vector, basically the 26 size array. Let's name it frequency. It will be of size 26 and initially all of them will store 0. Then we will iterate inside the string S for counting the frequency, right? So for character ch in S, what we will do? We will do frequency of ch minus a plus plus. So basically we are converting that particular character to a number for the index, right? We are doing minus a. So it will deduct the ASCII code of lowercase a from that particular character and we will get a index between 0 to 25 for each of the characters, right? So now that we have counted the frequency, we will create a string result for our answer, right? And we will take a index current which will initially be 25, right? Now, while our current is greater than equals to 0, what we will do? We'll first check that if the frequency of current is equals to 0, then that means no character has to be inserted, right? So we will simply do current minus minus and we will continue, right? Otherwise, if the frequency is not 0, then we need to take the minimum of repeat limit and the frequency, right? So we'll take a variable use and in this we will take the minimum of frequency of current, comma, repeat limit, right? So in the result, we will append that particular character use many times, right? So the number of times is used and the character will be A plus current, right? Because current here is a number. It is an index of our frequency. So we are adding small a over here. So it gets converted into its corresponding character, right? And since we have utilized this many frequency of the current character in our frequency array or the vector, we will decrement this, right? Now, after doing all of this, if the frequency of the current character is still greater than 0, then that means we need to use one frequency of the next character, right? So we'll take a variable next, right, for finding out the next character, and it will start from the index current minus 1, right? Now, while our next is greater than equals to 0 and the frequency of next is equals to 0, we will keep on moving towards the left, right? Now, after doing all this, if our next becomes less than 0, then that means we cannot find any character to be used as a breaking character over here. So we will just break, right? Otherwise, in our result, we will push back that particular character. So a plus next, right? And since we have used this character next one time in the frequency vector, we will decrement its frequency by 1, right? And then at the end, we can return the result. So let's run this. So in this particular case, if you see, first we are traversing inside the string s and updating our frequency vector. So this will be n times, right? Then this loop is running for current, and current goes from 25 to 0, that is 26 times, right? And then inside this we are also having another loop which finds out the next character, right? And that is also 26 times in the worst case, right? So we can say that the time complexity of this code will be n into k, where k is constant. K is 26, right? Because the number of unique characters that we are having is 26, right? And since here we are also appending that particular character in the result, so this will also take in the worst case n time, right? So this will be a time complexity and space complexity. So since we are taking a vector, right, for storing our characters and its length is 26, right? So we can say is order of k, where k is nothing but 26. So let's submit this. So it got accepted. Now there is one more approach for solving this, that since we wanted to find out the maximum character, right? We always wanted to find out the maximum character. That is why we took the current from 25 and we moved towards the left, right? Instead, what we can do is that we can create a max heap, right? Because max heap will always store the largest character at the top, right? So what we can do is that we can create a map, right? Now this map will only store the unique characters that we are having inside the string S with their frequencies, right? So the only unique characters we are having are A, C and Z. A is coming 2 times, C is coming 4 times and Z is coming 2 times, right? So this map will now contain only the unique characters present in the string S and not all 26 characters, right? And then we can create a max heap, right? We can create a max heap named maxi, and then inside this we can store our characters, right? So this will store as ZCA, right? So what we can do is that we can take the first character, right? We can remove it from the heap, so it will come out to be Z. Again, we will check its frequency and we will take the minimum of these two and we will append Z these many times, right? Now, if still the count of Z is not 0, we will take another character, that is now whatever is the top character that we will take out from the heap, right? So in this particular case, Z will be appended 2 times, so its frequency will become 0, right? So we will move to the next character. So now we will take out C. So we have taken C out. The frequency of C is 4, repeat limit is 3. C will be appended only 3 times, right? Now we will see that its frequency is still greater than 0. So now we will take the next character from our heap. So next character is A. A will be taken out. And from A, we will take only one frequency, right? So this will be decremented by 1. A will be appended here, right? And then if after consuming one frequency of A, still its frequency is greater than 0, then we will append this A back to max heap, right? So we will append A back to max heap, right? And then again, since C is still non-zero, we will append C also back to our max heap, right? Then the next iteration again, you will take C out, right? Then for this C, we will take the minimum of this. So 1 will be the minimum, C will be appended here, count will become 0. Now this C won't be inserted back into the max heap. In the next iteration, you will take A out, its frequency is 1, limit is 3, 1 will be appended here, and its frequency will become 0. And since it has become 0, we won't be pushing it back into our max heap, and now our max heap has become empty, so we won't insert anything into our heap, right? So in this particular case, we have avoided to go all the way to the left to find out the next character. We will only be doing the push and pop operations from the max heap, which will take log k time, right? Where k is the number of unique characters inside the string s, right? So in the worst case, it will be 26 if let us suppose that the string s is having all the 26 characters, right? So in that particular case, it will be log of 26, right? So with this approach, our time complexity will be order of n log k, where k is the number of unique characters inside the string s, right? And space complexity wise, in our map, we will store only unique characters. Inside the max heap also, we will store only the unique characters. So the space complexity will be order of k, where k are the unique characters in the S, which in worst case can be 26, right? So let's quickly look at the code for this approach as well. So here, first of all, we have created an unordered map in which the key is a character and the value is an integer for counting the frequency of each of the characters. Since in the map, we do not want any order for the characters, the order will be maintained in the max heap. So we can take an unordered map over here. And then we are updating the frequency of each of the characters in string S inside our frequency map. Then we have taken a max heap using a priority queue, which will store character and its name is max heap, right? Then in the frequency map, we are iterating and inside our heap, we are pushing our character, right? Then we have taken our result string. Then we are looping that while our max heap does not becomes empty, what do you do? Take the top character and pop it out from the heap, right? Find whatever is its frequency from the frequency map. Then take the minimum of that frequency and the repeat limit. Then whatever it is, append it those many times inside the result and decrement its frequency by those many times. Now, if still the frequency is greater than 0 and our max heap is not empty, right? Because if our max heap is itself empty, then we cannot find any other character, right? So we won't go inside, right? So if the max heap is not empty, take the next character which will be present at the top of the max heap and then pop it out, right? Then push back that particular character inside a result string and decrement its frequency by 1. Now, if its frequency is still greater than 0, then push it back inside the max heap. And then since here the frequency of our character was already greater than 0, so this character has also to be pushed back inside our max heap, right? And then at the end, we have simply returned the result. So this is how we can solve this problem using a max heap. So let's quickly run this code as well. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.